Hi, today I'm going to be doing some talking about the OCR GCSE Geography for changing climates. Today I'm going to be focused on two aspects of this topic, which is evidence for climate change and the human and natural causes. So let's get into it. So as I'm going through this, what you might want to do is either use a mind map, or in this case I've used an example of a threshold concept grid. You can see an example here. My class, you will have a paper copy of this that you can fill in. And the way you should do this is try and do it in different parts. So first of all, you should try and complete this without looking at anything. And that's the same with mind maps as well. Try and complete them without looking at anything. What do you know? What do you know about the causes? What do you know about the evidence without even having to look at anything? Then, if you start to get a little bit stuck, with a different coloured pen, you can start using some visual clues or your own notes for revision to help you try and complete some more boxes. And then finally, if that's still struggling, then obviously you should be looking for your teacher to give you some guidance on some other aspects. Now, as I'm going to go through this video, this will be me giving you some support to be able to help you fill in hopefully some of those boxes as you go along. So it might be a good point to pause here, get your threshold concept grid, create your mind map, and be ready to start trying to think about what you can do by yourself first. So if you've now continued, it means that you might be struggling just a little bit, or you might have a few gaps. So here on this slide, you've now got some visual clues, links to some key things we need to know about changing climate and climate change, and some examples of causes and evidence. So this again should kind of start to stimulate you, give you some ideas of things that you can also include to try and add on. And remember, you should be doing this in a different coloured pen now. So you're showing the difference of what you know and what you remember, and what you might need some help with. So this should start to give you some more ideas. So again, you may want to pause, carry on, and then come back to this when you're ready to do so. As I go to the next slide, we will then start looking at some key ideas that you might use to be able to fill in the last gaps that you might still have. And again, you'll be wanting to use a different coloured pen. So this is the teacher support bit. So I'm going to be going through some key ideas now that you might want to think about and consider. Now I won't be giving you all the answers here, but should be signposting you some clear directions of what you can do to help. So remember, when we talk about climate change, when in this topic, we're looking at how the climate has changed in the last 2.6 million years. Now remember, this key area then is broken up into these two parts. So the Quaternary period is our main period of time that we're looking at. And it's broken up into these two parts, which is the Pleistocene and the Holocene. And as you can see from the table there, you can see that the Pleistocene lasted from 2.6 million years ago to about 11,700 years ago, and then the Holocene has been from then till now. Now, generally, the pattern that we talk about then is you can see from the graph here that from 2.6 million years ago, you can see that the Earth started to become colder. Okay, and over from that period to 11,700 years ago, the temperatures stayed cold. Now it's only recently, okay, or got colder even. It's only in the last 11,700 where we start to see an increase in temperature again. So this leads us on to talking about this graph. Now along this graph, we can identify kind of some key things. The first one you can see in the orange box at the bottom there, it shows you that this graph is working kind of in these 400 years, 1,000 year cycles, where we have periods of warming and periods of cooling. Now you should be able to identify that the periods of cooling take a lot longer than periods of warming. The periods of warming tend to be happen very quickly, and you can see from looking, if I show you using on here, you can see around this point here, around kind of 325,000 years ago, just before that it was extremely cold. But now it shot in that short period of time, it shot up. Now you can see that how these spikes. Now remember, we have our glacial periods, our periods of cooling, and our interglacial periods, our periods of warming. Now if you look at the final point across on the far side, kind of close to the present day, now it's clear that something different is happening here. Because if we look at in the kind of the last couple of key cycles where we've seen these spikes, well actually, okay, that we can see that this period of time, the warming has been more consistent over a longer period of time. and actually is lasting longer. By now we should be cooling down again, but it's not, doesn't seem to be the case. Again, showing you what we mean then about these glacial and interglacial cycles. So again, you can see that every roughly 100,000 years we see these interglacial periods. But if we look at the modern day, our interglacial period is lasting much longer than it would normally happen. So we kind of at the point now is kind of, okay, this is the situation we've got, this is what we can see, so now what? So how do we know that this is evidence? How does this show us that something's different, changing? So some key evidence then we need to be able to know about then to be able to justify. So first of all is temperature. Now temperature records have only been around since about 1880. So we can only really go at just looking at how the temperature has been recorded over time. Now in the last kind of 100 years we've seen a temperature increase of 1 degree, which sounds very, very small amount, but actually that is a big difference. For global temperatures change by 1 degree is very unusual. So it must be a sign that something different is happening and our climate is changing. Ice core data then. Now, as I said, temperature data doesn't go back too far, whereas we can use ice cores to look into the past a lot further. So ice core data can go back to sort of far as 800,000 years in some parts of Antarctica, the Vostok ice cores being a key example of that. Now, ice core data is really useful to tell us what climate would have been like in the past. It can look at how many CO2 bubbles are trapped in the ice, and we can kind of look at, and we've found a correlation between CO2 and temperature. When there's more CO2 in the atmosphere, the temperatures are higher. When there's less CO2 in the atmosphere, the temperatures are much lower. Now, if we look at our ice core data, this supports this notion that during periods of cooler, there was less CO2 in the atmosphere. In periods where it's warmer, okay, we can see there's a lot more CO2 trapped in the ice. So, really useful piece of evidence. Here you can kind of see then how some of this data has been tracked over the last 450,000 years. And again, it looks very similar to the graphs we've looked at before. So there must be a correlation between the two. And again, if we look at the most recent, you can see that this period of warming, okay, and the amount of CO2 is kind of at its high, one of its highest points. Now, actually, if I was to take this graph a little bit further, okay, and bring it a bit more in today, in 2015, the UK received, okay, had 400 parts per million of CO2 in the atmosphere. So this would go way above what the last 450,000 years have shown, which shows that we must be having an impact also. A few other pieces of information we can look at then, or evidence. Sea ice positions. We can look at how much sea ice, okay, has been calculated and can see from satellite photos, but also data suggests how much sea ice there is to show that actually warmer temperatures must be the case. Because if we look at the sea ice in, let's say, the Arctic at the same time of year, each year, then we may see changes or a decrease in the amount of sea ice every year. On this graph here, you can see that over time then, the amount of sea ice, okay, million square kilometres, has slowly decreased, 2012 being a particularly bad year. So again, this supports that notion that something's happening, something's changing, if over this period of time we're seeing the lowest records of Arctic sea ice we have for a long period of time. Another thing we can look at is glaciers. Similar to Arctic sea ice melts. So every year glaciers retreat. But if they retreat further than the year before, then that shows that the temperatures must be warmer than the year before, as they are moving further back up the mountains that we generally find them in. We can use photographs to evidence this as well. So you can see here two photographs of the same area, showing that how at the same time of year, well, one in 1921, we can see that this glacier is quite far down. If you look in the photo here, where I'm circling with the dot, you can see it's quite far down the mountain, whereas here we can see that all that ice is not here now, and what we call a moraine, which is kind of the leftover material of the glacier after it's retreated higher up. So we're now only seeing those ice and those glaciers forming in high altitude places. Now, one of the things we can look at as well, which are useful but not always as reliable, is pictures and diaries. Now here shows a painting of Belgium in the medieval times. Now we wouldn't necessarily associate Belgium with this kind of image anymore. We wouldn't expect it to get these quite harsh winters with everything covered and there's people ice skating on the ice. It doesn't get cold enough for that. You've got to think Belgium's got a similar kind of climate to the UK. So if we're not going to see it in the UK, we're not going to see it in Belgium. I've also seen examples before of paintings of the Thames freezing over. Now again, that's not something that we associate with modern day time. So we can use these as evidence because where painters have made these are obviously in times where the temperatures or climate must be much colder. However, are they always reliable? We know that obviously people can exaggerate or remember things wrong, and so this might not actually be a fair representation. It could have been warmer than this and the painters interpreted it differently. So again, we have to be careful with kind of things like this. Diary entries are another example of obviously something that can be useful. In previous lessons, when you've looked at polar regions in sustaining ecosystems, you've seen interviews with Inuit people living in the Arctic who say, oh yeah, the winters are nowhere near as harsh as they used to be. Our ice stores are melting, so we can't store our meat as well as we used to in our ice caves underground. Also, people in places like Tuvalu, who are places which are very low, only 1 or 2 meters above sea level, they say that the tides are coming in a lot higher than they used to. The storms are a lot more dangerous. Now this is people's views. We're not saying that they're lying, but what they might do is exaggerate what they've been saying. So again, we've got to be careful how we use this, but at the same time it is useful to give us an account, an idea from a human aspect of what it might be like. So moving on then, we can now start to think about our causes. So we've looked at the evidence, now look at our causes. We need to look at this in 2 ways. We need to look at the physical causes and the human causes, because we need to be able to assess whether we actually think, can we just blame humans for climate change? It's what we see in the news and every day, and you know, during the current process that we're going through at the moment, we're hearing lots of things about how, you know, the amount of CO2 is dropped off and this is really good for the climate because not many people are using cars and things like that. But is it just down to humans, or can we look at other things? So the first thing we can consider here is sunspot activity. Now, roughly every 11 years we see this sunspot cycle where these kind of black dots you can see on the image of the sun there are basically kind of where the sun's kind of burning, really, kind of erupting in a sense. And it's giving out extra solar radiation. And this can then lead to warmer temperatures on the Earth. However, scientific evidence suggests that this only actually impacts on the global temperatures by about 0.1 degree. And we've already mentioned in this video that temperatures have increased by 1 degree in the last 100 years or so. So even though they may have having some impact, their impact is actually quite small. So worth remembering. Another factor that can obviously increase the likelihood of climate change is volcanic eruptions. Now, volcanic eruptions can cause big problems, obviously for the local areas, okay, but also into the atmosphere. When these eruptions take place, lots of ash and gas are pumped into the atmosphere, and this can obviously circulate around the whole globe. Now, actually, sometimes what can happen when the ash kind of collects in the atmosphere for a period of time can actually cause the climate to lower. The temperature can decrease because it can block the sun's energy. However, also the amount of gases that are released, so for example like CO2, it can cause widespread problems, and obviously this is going to over time could lead to an increase in temperatures. Now in the UK we produce about 500 million tonnes of CO2 a year, if not more now, whereas this actual volcanic eruption produced about 20 million tonnes. So you know, that's a small country's worth of CO2 emissions from one volcanic eruption, so it is going to make an impact. But again, on a long term and how frequent these take place, is that as much as compared to the whole of a country's CO2 emissions? Again, probably not so. So, the last thing we need to consider then is something called the Milankovitch cycles. And the Milankovitch cycles has 3 clear different types of orbit going on. which can have a big impact on the UK's climate. And if you think back to what we said at the beginning of the video showing those interglacial and glacial periods, this may be something that can have a greater impact. So every 100,000 years the Earth's orbit goes from being circular to being an oval. Now think about it. You can see from the circles here on this diagram that obviously at periods of time, if we've got this shape, the Earth's going to be closer to the Sun, which means the Sun's radiation is going to probably be stronger, which can again lead to warming of the Earth. As it moves back to an oval, a circular shape, it goes can be further away at some parts, so it may lead to cooling. Now another type of Milankovitch cycle is the Earth's tilt. So the Earth spins around on its axis and it's tilted over. Now as the Earth spins, and over a period of time, this tilt can change slightly. So in the diagram you can see the North Pole pointing slightly towards the Sun, whereas sometimes the North Pole might be further away. Now this changes every 41,000 years. So at periods of time when the North Pole is maybe closer to facing the Sun, maybe the Arctic will feel warmer, leading to greater ice melt and things like that. Whereas actually in Antarctica might be actually facing the opposite, where actually it's further away, facing further away from the Sun, and actually could be colder. So we have to consider that as the Earth spins. And think about then obviously if the North Pole became more tilted upright, how would that impact? Now the Milankovitch cycles are quite complicated, so you might want to go and look into this in a little bit more detail as well. The final one then, is as it's on this axis, it wobbles a bit, and it wobbles around this 23 to 25 degree axis. And this happens every 26,000 years, and this cycle works every 26,000 years. And again, this can lead to sun intensity on some areas different to others. So where some places may be used to a particular type of climate, this might change. So it could lead to, for example, like rainforests becoming drier than they're used to being. Or again, the poles becoming slightly warmer than they're used to have been. So again, this cycle can obviously have an impact. So when you go back, one way to look at this and see if this is the case is go back to your graph at the beginning. See, can you map these different Milankovitch cycles against the interglacial and glacial periods we've seen over time? Can you pick out the patterns? It's probably the case that you will be able to see that. The final thing then we just need to finish with then in terms of content then is the greenhouse effect, and this is where the human causes come into a little bit more. Now remember, the greenhouse effect is a natural process. Sun's radiation comes in, heats the Earth. Some of that heat gets trapped, that helps keep our Earth warm within the Earth's atmosphere, and some of that heat is reflected back into space. And this is fine because it keeps our planet warm and inhabitable. If we didn't have this, the Earth's average temperature would be negative 15 degrees, so much colder than we could be able to survive on. However, what we've now noticed is though the greenhouse effect is being enhanced, and this is by human activity. So because there's more greenhouse gases in the atmosphere due to some of the reasons you can see on the right hand side there, what that means is more heat's being trapped into the Earth's atmosphere, less is being reflected back into space. So it means that more heat is being trapped, causing our global temperatures to increase. So on the right hand side there you can see some of these factors. So burning fossil fuels, deforestation, dumping waste in landfill, agriculture. These are all contributing to more greenhouse gases being in our atmosphere, which is going to obviously cause the Earth's warming to continue. So one of the things you might be asked to do is consider, actually, do we blame humans, or is it a natural process, this climate change that we're currently going through? So to finish off then, you've got some exam questions here. First of all, you've got a nice little 4-mark question. Explain how changing sea ice positions provide evidence of climate change. So go back to that slide, go back to your notes about sea ice positions, explain what do they show, why are they useful, why do we want to talk about them. Remember, it's 4 marks, so you want to try and either pick out 2 points and fully explain them, and that will probably get you onto those 4 marks that you need. The next question then, describe the advantages and disadvantages of using paintings and diaries as evidence for climate change. So really simple way to break this up, 2 peel paragraphs, one talking about advantages, one talking about the disadvantages. Why are paintings useful? Why are diaries useful? Why are they not useful? Why do we have to maybe consider them not to be as good useful? The other way you could do it is maybe do one paragraph about the paintings and talk about the advantages and disadvantages of the paintings, and then do the same with the diary entries. What you want to, the key thing is with this question is that you're showing a good balanced argument to get all 6 marks. Try and bring in examples. Remember, in climate change, we don't have specific case studies to talk about. We have some examples of places that we touch upon and mention, but there isn't a set case study. So this is a good opportunity for you to bring in just good, nice examples that you've read about and looked at. So use your notes, okay? Use your research to help you bring in some good examples. Like I say, the Belgian painting from medieval times, the photos from the Thames, paintings of the Thames being frozen over. Those things would be useful. Look at diary entries, maybe of Inuit people or people who live in places like Tuvalu. These will, these are your useful evidence in your appeal paragraphs that will get you onto those top marks. The final question then is our kind of top level type of question, an 8-mark question, which has got that phrase, that to what extent question in again. So climate change is a naturally occurring event. To what extent do you agree with this statement? Now at the end of this video, we've talked about the human and natural causes of climate change. This is an opportunity for you to basically have what the examiners like to call a discussion now, to show the different aspects of this point. Can we talk about how natural causes have a factor? You may want to talk about 2 or 3 different things in that. So you could talk about Milankovitch Cycles and sunspots, for example. That's probably, or you might even want to bring in the volcanic eruptions as well. But because it's saying to what extent do you agree with the statement, we want to also bring in the human factors as well. And actually, are humans having a greater impact probably than natural causes? And it's asking you really to argue that point. So just because the quote says climate change is a naturally occurring event, that doesn't mean you're just talking about the natural causes. You've got to basically bring the counter argument to that point. Actually, no, it's not just down to the natural causes. These are the human causes, and this is why they are also causing problems. So really consider that in your writing. And because it says to what extent, try and give it value. So I strongly believe that this statement is incorrect, or I slightly agree with this statement because it can do, etc., etc. So using that value to say how much you agree with something or disagree with something, again, is that evaluative skill that's really important to get onto those top level marks for a question like this. Now remember, before you do, especially that 6 and 8 mark question, bug the question, break it down. What is it asking you to do? And again, maybe what you want to think about is bullet point your evidence. What are you going to bring in? What information are you going to bring in? How are you going to show your knowledge and understanding of this particular topic to the examiner to make sure that you're showing that you've got a really good understanding of climate change? So have a go at these questions, and as always, drop them in an email, photograph them, show them to your teacher in lessons to have a go at really showing how well you're writing in these exam answers. And as always, any questions, please get in touch. See you soon.